Hey, what's up everybody? So this is a little presentation on some of the CAD/CAM experience that I've had as a teacher in my classroom getting started and some stuff more recently. I used to work at Gateway Regional High School. I worked there with my buddy Chris Better. We went to college together at TCNJ. He's really the one that had the guts to, at first, because I didn't know anything, to argue for all this equipment and get it put into our budget for the renovations we're going to do to our classroom. And yeah, our second year teaching together, we had this huge renovation of facilities, and it included having some CAD/CAM equipment. So we had a room that was designated just for computers, and in there we had a 3D plastic printer, and we had a laser cutter, a CO2 laser. All the lasers you're going to use are CO2 lasers. And you'll see an example of the same one that we had up there at the Makerspace the other night. This is actually a picture of our classroom wall, or the big bay door in the back of the classroom. And you see a nice big tag up at the top for D&T, Design and Technology. We had a student go up on a cherry picker to go up there and do that. And then just some different graphics of things we cut out with the laser cutter and had hanging up around the room. The Epilog laser, the universal lasers, those big ones, you know, they cost a few bucks for that 3-foot by 2-foot bed. And the bed even goes up and down to accommodate like taller things. You know, that was like $20,000, but you can get them for a couple grand now. The idea, though, is if you spend more money, you can run these things 24 hours a day. And you may find that once kids realize what you could do with these machines, that you're going to have jobs queued up all the time and be looking for all kinds of scrap material, anything you can get your hands on to engrave or cut out safely. One of the first things we messed with was plexiglass or acrylic, and that stuff's clear, right? But when you engrave onto the surface of it, those scratches that show up in the plastic are going to diffract the light. And so we just took this big sheet of plexiglass and we engraved the logo and the words on the surface. And then we took some LED lights and bought a little strip of LED lights, and we ran that strip just up along the top edge. You can't see it. And those LED lights blasted down right up against the edge of the plexi. And so the light travels through the plexiglass and then picks up anywhere that it's engraved or scratched. Side note, there are two types of plastic for plexi. You can get extruded plexiglass and you can get cast plexiglass. Most of it is cast. We found out that if you buy the extruded stuff, the lines from the extrusion process will show up when you engrave, not work so well. But one of our first projects, we started making lots of signs. In fact, I had some students that were making big bar signs for bars in town, you know, back in the early 2000s. Big Eagles heads, light up acrylic Eagles heads, and for the Philadelphia Eagles football team. And I think we even got a cease and desist letter at one time because kids were selling these signs to the bars for, you know, upwards of $500. We cut out some vinyl letters. You know, you can buy the vinyl letters, a sticky back vinyl, just these little thin sheets of plastic, and then cut these letters out that people could stick to things. And we found out later, of course, that PVC, polyvinyl chloride, is not supposed to be used in a laser cutter because the gas that it exhausts is toxic. Luckily, we had our exhaust hooked up and all the exhaust blasts outside of the building. So nobody was really in any danger, but it's not something you want to be doing in your classroom, that's for sure. We messed up on this one here. You can see with my cursor, we cut out the whole, you know, the perimeter of this plexiglass was cut out. Right, and as we cut around, now when the light shines up from the bottom, the LEDs are down here in this box, the light shines up. Once it gets past this part of the bone here, there's no plexiglass here to keep catching the light and moving the light through. So we realized we can't be cutting shapes out like this. We just had to leave this as a full sheet all the way up and then have the image engraved in there. Then we started finding different tones of plexi that had a light blue tint. And we'd cut them out and embed them in there. This was all just playing around, finding different graphics, and maybe messing with the graphics in Illustrator or Inkscape, but you don't have to have that to be successful. This is for a big bar in Fishtown. This thing is 3 foot tall by 2 feet wide. We found a piece of white Corian, the kind of stuff that you make, you know, the kitchen countertops can be made of. And we had this big scrap piece of Corian. It weighed a lot. And, you know, the Corion's white. And so if you engrave the Corian, it still shows up white. You can feel the engraving with your fingertips, but there's no contrast. So we took the white Corian and we spray painted it with black to cover the surface. And then we found this image of Charles Dickens. The bar was called Dickens Myth. And we took this image that was like a pencil drawing of him or a photograph, and we converted that image, right? It was into black and white. It was already black and white. And then we actually reversed the image, made a negative of the image, right? Right-clicked on it, just created a negative, and then it turned all the black in the image to white and all the white to black. That way, wherever we engraved, where the laser saw black in the image, it engraved, and that black part, when it got engraved, showed up white because it was spray painted. The spray paint's being removed by the laser, revealing the white underneath. So that's how we got this nice contrast in this image. And we cut the head out, mounted it up here, this big, huge, gigantic sign made of 2x10s, and then even cut the letters out. They were poplar, boards of poplar, a ½ inch thick. Cut the letters out, spray painted them, mounted them to the sign. Some more plexiglass where the pieces are cut out individually and then arranged onto this signboard and hung up. A lot of fundraising stuff. You know, people would come to the classroom and we set kids up like it was a little design studio, and kids would hear your problem and they would write a design brief with requirements on it, and then maybe even do a sketch or some little draft of what the thing might look like. And then people would make donations to our club, and we were able to keep a little revenue accruing account that we would use to go back and buy more materials and things for the classroom. Again, here the letters were cut out of plexiglass and then spray painted. And then over there on the right, we've got that arrowhead was cut out. The pine cones and the tree were cut out separately and then glued onto the cutout of the arrowhead and painted afterward. We were making little trophies for fun events and things going on around the school. That's where we first saw two-tone plastic. So if you look at the winner at the bottom, this thing here, this is a typical placard thing you might see hanging up over a door with the numbers for people's doors or the nameplate for somebody's desk. And two-tone plastics are just like they say, it's a layer of plastic that's one color, and the second layer within that sheet is another color. And when you engrave onto the surface, it removes that first color, revealing the color underneath. So this was gray and black two-tone, or silver and black two-tone plastic there. We found out it was really cool if you cut something out on one material and then took the same image and cut the negative out of another material, that the first cutout would pop right into the second one. So we started to cut out letters and then pop them into their negative spaces. We had a hot wire bender in the room. It's like this little strip machine, a strip of a hot heating element, and you could lay the plexiglass over. And when the plexiglass would get warm, you could form it and bend it, and then let it cool, and it would stay in that shape. That's called a Thermo forming plastic, meaning that you can form it after it's warm. When it cools off, it'll stay in that position. A Thermo setting plastic is different. That's something that once you heat it up and change its form, it stays there. Kind of like if you're heating up plastic pellets and pushing them through an extruder to injection mold something. That heats up once, changes shape, and it stays like that. Acrylic plexiglass is different. We can heat it up, bend it. When it cools off, it'll stay in that position. Pretty cool. We messed around with some glass. We had students taking different pieces of glass, and then we would engrave away the surface. We found out that it works, but it's not as clean of an engraving as if you were to take engraving cream, one of those etching creams, and put that on the surface. It just makes a nicer texture. And then, of course, we found out it was even better if you engraved the image onto the back of the glass so that when you're on the front of the piece, you couldn't feel the image itself. And so if you did that, you'd have to flip the image in reverse. and engrave it onto the back. And then we went in with paint and painted into the spots with a brush where we had engraved. We got a little better at that as time went by. There's a better sign we made for a local business in town that donated some of the first piece of hydroponic equipment that we had in our classroom. We were making the light strips at first, then we were able to buy them on some websites where they say a little strip of LEDs with a 9-volt battery clip attached. And then we thought, well, it would be kind of cool if we could engrave something and then pour epoxy over the top, you know, like a bar top or something. So we would engrave into the surface of the wood, or the plywood, whatever it was. And then we would engrave a couple times. We'd take that same image, the Bridgeport Marina, we engraved it a bunch of times. So the depth of the engraving was like 1/8 of an inch. And then we took a plastic syringe, no needle, just the syringe part, and would fill the tubes up with different paints. And if the board is sitting flat on a leveled surface, you could inject, shoot out some paint into the engravings, and then the paint would level itself out. And you'd have these nice thick painted letters that were built into the surface. Two-tone plastics in sheets, posted up on plaques on the wall to keep a record of student achievement. This is a mirror. We found out, a mirror is a piece of glass, and on the back of the glass, it's painted with a chrome paint. That's what makes it reflective, right? So if you go to the back of the mirror and you engrave away the paint, leaving only the glass behind, you could see right through that glass, right through the letters. So we engraved the letters onto the mirror, but in reverse, right? So that from the front, when you put your hands across the mirror, it just still feels smooth. Thin plywood, cutting out, glue some magnets to the back, make a bunch of magnets for the bus department. Here's some more Corian sink cutouts we had. The shop was throwing out. We would go out and pick up 50 of them at a time from the shape of the sink that was cut out of the Corian they weren't using. This is black Corian. When you engraved it, it would show up gray. And we made some pieces for some Boy Scout stuff. Take a piece of soft stone, limestone, right, really any stone, because you're not going to engrave the stone, but you're going to shoot spray paint all over the stone and then engrave away everything else. So we left the image itself, but engraved around it. That's one of my hydroponic systems in my old classroom. You see the big blue fish tank on the left-hand side, 1,000-gallon livestock tank. But the Grow Hydro letters at the top were cut out. That's kind of it on that presentation. Now I want to slide over here and show you some other stuff we made. Let's bring this over here. There we go. This was a guitar pickup cover. So on somebody's guitar, the pickups have an electric guitar, has this little chrome cover over it. And what else you can do with a laser cutter is marking. It's called marking. It's where you, something like metal or ceramic. They make these sprays of a special kind of paint. It just looks like spray paint. But when you spray it on, you spray the paint onto the surface, and then you engrave your image onto the metal or onto the ceramic. And of course, we know that the laser is not going to be able to engrave metal. Like the light hits the metal and bounces off. But if this paint is on the surface, the laser hits the paint and photochemically bonds the surface of the metal to the paint itself. And then whatever's not bonded, whatever was not hit with the laser, can wash away. And so after we put this thing in the sink for a second and rinse away the paint that wasn't hit with the laser, you're left with this black image that's marked onto the surface. So any metals with chrome in them, nickel, will really do a nice job with the metal marking. And there's also ceramic marking, so you can mark glass and pewter and other ceramics with a different marking paint. These were stencils. So we would find an image of somebody, Marilyn Monroe, right? And we would take that image and make a high contrast image out of her face, which means it takes the regular graphic and then takes the lighter parts and makes them completely white or invisible, and then the black parts and makes them completely dark black. So this high contrast image can then be cut out, So we cut the image out of Marilyn Monroe and basically made a stencil. And then we took that stencil and held it over top of this piece of plexi and spray painted black through the stencil so we could spray paint, repeat that graphic wherever we wanted with the stencil. Here we were cutting some letters out of a piece of plexiglass. You can see that's the head of the laser that moves back and forth. You can see that that sheet of plexi is actually covered in a paper layer, paper sticky layer that you peel off, and the plexi comes covered in that layer of paper just to protect it from getting scratched while it's moving around. And you can leave it on when you cut things out. So here we are cutting out the outline of the letters. So I said when you're using the laser, it sees images in black and white and it will engrave those. But depending on if you want to cut something out, the laser just needs to know, oh, this line is for cutting. And in Illustrator, that's going to be a hairline. In another program, it might be a dotted line. But those hairlines, dotted lines, those when a laser cutter software sees that, it knows, oh, okay, it's time to cut, not engrave. And you can get lasers in different wattages. 30 watts is kind of low, 60 watts is even stronger. With a 60-watt laser, the laser can slow down and cut through a 1/4 inch of plexiglass in one pass and leave a nice smooth edge. Two-tone plastic there. Some more stencils. These are some point-of-purchase displays where kids had to make a box where they could draw attention to a product. They incorporated LEDs in the laser cutter. I remember we did a workshop where we were trying to come up with ways to not spend $1,000 on the HEPA filter. So if you have an exhaust pump, it's just this big pump you plug in, this vent that moves air out of the laser cutter outside of the building. Try to set those exhausts up as by themselves. They're not supposed to be set up with your dust collector or with your fume hood and your sinus collector. It's its own separate exhaust. And it would just go out of the building. But if the exhaust going out of the building happens to be too close to one of the air conditioner intakes or something like that from the HVAC, you don't need the fumes from the laser cutter coming back in the building. So an indoor filter is great. You can buy them for like $1,000. They're sold with the lasers. But you could also build your own. And so this gentleman built his own, a 5-gallon bucket full of charcoal. And he's got a little charcoal filter here wrapped around and then charcoal inside the bucket. And air has to come through this bucket, the exhaust through, to make its way back out. Pretty neat. Here's another CAD CAM example. This is the head of our principal at the time. I remember we walked around with an iPad, and it had a piece of software on it that you could take a picture of a 3D image, some real thing in real life, walk around, take a picture from all these different angles. And after taking 15 pictures, it generates a 3D file of your object, an STL file. And then it would break that file into layers, and then you could take each layer as an individual image and take it to your laser cutter, and we cut out the layers. So we cut out all these layers of the head and then assembled them back together, and we used them for for mini golf. And that's what the head looked like afterward. And each student the students were making mini golf holes and as part of class, and then we used the mini golf, set it up in the gymnasium. It was a fundraiser. People would come play each hole. And that was Mr. Hyman's head. There's the ball return there. This is kind of crazy. It's a tie made from just a thin piece of alder plywood. And you can see that the tie flexes and bends. It has so many cutouts in it that it can flex. And you see people making cool stuff where they cut so much out of the material can actually curl or be bent around. So again, just a piece of alder plywood. Alder, A-L-D-E-R. It's a kind of wood that makes a really nice contrast. When you engrave, it shows up real dark, and it cuts out easy. We had students designing their own little standards and rulers and jigs and things that would be done to exact measurements. This was a way for them to be converting measurements and use the scale and proportion stuff when they were designing in Illustrator or Inkscape or whatever software to then make things like make rulers and stuff for class. There's no end to what you can do with the laser cutter, cuttings, engravings, customizations. flat furniture, making flat pieces that could be assembled into 3D products. Last year in class, we had somebody really do a lot with the lasers for their final project, where they wanted to spend more time with them, and they went up to the makerspace using all that awesome equipment. He turned his daughter's head into one of those Victorian side profiles, and then cut out a bubble wand. Pretty cool. So those are some of the things that can be done with a laser cutter. I hope this gives you some cool ideas. I know you played with them. You got to see an example of them over at the makerspace. And we're going to spend more time with 3D printers too. So this is just a little introduction into some of the cool things I got to do with my laser cutter, starting from knowing nothing and then having a lot of fun for years and years in a row, where this thing was running 24 hours a day in the classroom and all night running jobs. And just so much fun. It brings so much. You know, there's 5 ways to show your love to people, right? And the 5 love languages, and one of them is giving people gifts. You know, so students can make things for other people, make things for the community, make things for themselves. It's empowering. It's fun. You can be resourceful and creative and have a really good time with it. So if you're going to get some equipment in your classroom, say, hey, don't give me the race car without the wheels. I need those good wheels. Don't give me that new lab or that money for that makerspace without some CAD CAM equipment. All right. So that's all I have for you right now. Thanks again for your time, and I look forward to seeing you next time we meet for class. All right. Have a great day.